Okay, let's continue where we left off in the previous part of this lecture. So what we now have is our Atom sending data from the Arduino to the Helium network. You can see that the data is coming in every 5 seconds and it ends up in the request bin URL that we were provided earlier by request bin, and all the data says is hello Helium. It's just a fixed string of characters. What we'll do now is to make a little modification to our sketch to simulate data from sensors being sent over to our request bin. So on the left side, I've got the sketch that we saw earlier, and on the right side, a slight modification of that sketch. Have a look inside the loop. So inside the loop, in the previous sketch, we just had constant array of characters with the payload hello Helium, and on the right side I've replaced that with a little bit of code that allows us to send random data to the request bin. So I've commented out the const char data pointer to the character array, and instead the first thing that I do in line 42 is to create an array of chars, and you can see that its name is payload_message, and I've specified its size as well as 20 characters. I only really need 4 characters for the size of this character array, since in line 46 the function analog read will return no more than 4 characters up to 1023. But we are going to be populating the payload message character array with a little bit more data in the next example, so I thought I'd just put a 20 here. The key is to make sure that you allow enough space in your character array to accommodate all of the data that you want to send over. So it's okay to be a little bit more, but of course it's not okay to be a little bit less. I'm going to come back actually to the size of the character array in the next part of this lecture as well. So in line 42, as I said, we specify the character array that will receive our data. In line 46, we acquire just a random reading from analog pin 0 with analog read, and we store that as an integer inside random data. And then in line 48, we use this printf command. This is a C command that allows us to take a bit of data, formatted data, and store it inside the payload_message char array. So you can find out more information about printf if you follow this link here. You can find more information about printf, which has to do with the available formatting instructions inside printf by using this link here. And what I mean by formatting instructions, I mean those percentage followed by another character, like it could be an I, an S, a D. Depending on what it is, this value will be formatted accordingly. So if you want to learn more about it, I invite you to follow this link here. So what printf is going to do, just to repeat this point, is going to take this string of text. It contains a bit of fixed text like data with 2 dots here, and then it's got a formatting instruction, and this formatting instruction will be replaced by text depending on the value stored inside random data. We'll see this in action very soon. And then finally in line 54, nothing changes here. It's the exact same instruction in line 44 in the previous original sketch. The only thing that I've changed is to change the name of the character array. It used to be data, and now in my new sketch is payload message. And string len is another C function that returns the size of this character array. And everything else is exactly the same. The name of the channel we're using, the configuration of the Atom and how it interacts with the Arduino, all that is the same. So let's upload the sketch. And see it in action. So upload it. Let's go to the Helium dashboard first. So you see that there was a little delay here in sending the next packet. It's while the new sketch was uploaded, and here's a new data coming in. You can also notice how the size of the little dot here changes depending on how much bytes we sent across. So we had, I think, about 6 or 7 bytes here with hello world. It's a slightly bigger dot. Now we are just sending a little integer with a bit of text, so that's slightly smaller as a dot. And if I refresh this page, then we can see that in the debug log, we've got the new data coming in. And let's do that. Actually, I'll make this a bit bigger. There you go. And let's have a look at the request bin. I will refresh the page, and there's the data. A few seconds later, 5 seconds later, refresh again. Here's my new data, just random values. One more time. There's your data, another random value. So what we now have is our Atom with the Arduino sending random values to our Helium dashboard, and that being forwarded to our request bin. Great, so now we can simulate real data going across instead of just a fixed text, which is not very useful. What I want to do in the next lecture is to take this setup one step further. So I'm going to connect my prototyping shield with a couple of sensors and an LED on top of the Helium, and I'm going to get real data from the sensors sent over to the request bin as well. And I am also going to show you how we can send configuration values from the Helium network over to my device here, so that we can adjust the frequency by which my setup here sends data to the Helium network. So instead of sending data, say, every 5 seconds, I can remotely over the air configure it to do so every 10 seconds or whatever value I like. So let's move on and do that next.